Hello friends, welcome to Learner's Planet. Friends, this is our second session for Principle of Mathematical Induction. In the previous session we have discussed I think 4 or 5 problems. In this session let's discuss some more problems, some more varieties of problems based on mathematical induction. Just get ready with your paper and pen and start solving the problems right with me. Okay, so now see this problem, n plus 1, n plus 5 is a multiple of 3, right? Again, write down the statement Pn is equal to n plus 1, n plus 5 is a multiple of 3, right? So let's check the first, let's do the first step, P1, that is 1 into 2 into 6, right? That's 12. So 12 is multiple of 3, so P1 is true. Okay, now we see we have to assume that PM is true. So let PM be true. That means n plus 1, m plus 1, m plus 5, it is divisible by 3 or it is multiple of 3. If it is multiple of 3, I can write down them as 3k. Okay, now we have to prove that Pm plus 1 is true. Okay, now what is Pm plus 1? That's m plus 1, m plus 2, then m plus 6. Now what we can do is we can find out, see here we are having m plus 1, here we are having m plus 1. So m plus 1 is actually 3k minus m into m plus 5, or I can write down m square plus 5m. So finally it is minus m square minus 5m. So m plus 1 can be written as like this, right? So I write down the value of m plus 1 over here. So it is 3k minus m square minus 5m. Or alternatively what you can do is, I would suggest the better manner. You just open up the bracket, m plus 1, m plus 5, so that is m square plus m into m plus 5 is equal to 3k, right? I just write down the step over here. It's m cube plus m square plus 5m square plus 5m is equal to 3k. That means m cube plus 6m square plus 5m is equal to 3k, right? That is actually the first equation, first relationship. Okay, you must be having some space over here, so you just write down all the steps over here. Okay, now I take this once again. So similarly I just open this up. It's m square plus 3m plus 2 into m plus 6. Okay, that's actually Pm plus 1, and this is what Pm. Okay, so here it is m cube plus 3m square plus 2m plus 6m square plus 18m plus 12. So it is m cube plus 3m square plus 6m square, that is 9m square, but I want m cube plus 6m square plus 5m, right? So I just take this portion only, m cube plus 6m square plus 5m, right? Then I'm left with 3m square, this gone, 18 plus 2, 20m was there. Out of that 5m I have already written, so I'm left with 15m and then plus 12. Now this thing is what? 3k from equation 1, from the relation 1. So this is 3k, and this is what? I can take 3 as common. So m square plus 5m plus 4. So from the final statement or this equation or relation, I can take 3 as common. So k plus m square plus 5m plus 4. That means it is multiple of 3. Okay, so pm plus 1 is true. Whenever pm is true, pm plus 1 is true. Hence, by principle of mathematical induction, it is true for all n belongs to n. Okay, so all of these are standard steps for all the problems of principle of mathematical induction. Okay, let's take a few more. See this, 10 is to the power 2n minus 1 plus 1 is divisible by 11. Once again same thing, the first statement, Pn is equal to 10 is to the power 2n minus 1 plus 1 is divisible by 11. So first step, P1 is equal to 10 is to the power 2 minus 1 plus 1, that is 10 plus 1, that is 11. So P1 is true. Okay. Now next is let Pm be true. That means Pm is equal to 10 is to the power 2m minus 1 plus 1 is divisible by 11. So if it is divisible by 11, it will be equal to 11k. Okay, that is the first equation. We can simplify this. 10 is to the power 2m by 10 plus 1 is equal to 11k. So 10 is to the power 2m is equal to 11k minus 1 into 10. Okay, that is the relationship we have found out. Now we have to prove Pm plus 1 Pm plus 1 is also true. So Pm plus 1 is equal to that means 10 is to the power 2m plus 1 minus 1 plus 1. It is also divisible by 11, that we have to prove. Okay, so Pm plus 1 is equal to, it is 10 is to the power 2m plus 1, right? Instead of m, I put m plus 1. I'm sorry, I have written wrong. So it is m plus 1, so it is 2m plus 2 minus 1. So precisely it is 2m plus 1. Okay, plus 1. So that is Pm plus 1. So it is 10 is to the power 2m into 10 plus 1. Now 10 is to the power 2m we can put from here, right? 11k minus 1 into 10. So it is 11k minus 1 into 10, and this 10 also there, so it's 100 plus 1. So it is 11k into 100 minus 100 plus 1. So minus 100 plus 1 is minus 99. So I can take 11 common, 100k minus 9, that means it is multiple of 11, right? So Pm plus 1 is true whenever Pm is true. So hence by principle of mathematical induction, it is true for all n belongs to n, right? So you might have observed that all the problems based on this divisible by this same steps we have to follow, right? Pm we have to write down, from that statement we have to find out the value of these sort of expression, right? And we just have to put up the value of this expression over here in the Pm plus 1. Okay, so you'll be getting this number as common. So standard steps are there. You just have to write down all the question just 1 or 2 times. Okay. Similarly, we see this problem again. X raised to 2n minus y raised to 2n is divisible by x plus y. So Pn is equal to x raised to power 2n minus y raised to 2n is divisible by x plus y. That means first step P1, so it is x square minus y square, so it is x minus y, x plus y. So it is x plus y is factor of this, that means it is divisible by x plus y. That means P1 is true. Now next, once again, let Pm be true. So Pm is equal to x raised to 2m minus y raised to 2m, right? And x raised to 2m minus y raised to 2m, it is divisible by x plus y. Okay, so x raised to 2m minus y raised to 2m is divisible by x plus y. That means it is actually x plus y k. Okay, now we have to prove Pm plus 1 is true. That means Pm plus 1 is also divisible by x plus y. Okay, so I write down Pm plus 1 is divisible by x plus y. That we have to prove. So we write down Pm plus 1. So that is x raised to 2m plus 2, because instead of m I'll be writing down m plus 1. So m plus 1 into 2 will be 2m plus 2 minus y raised to 2m plus 2. So it is x square into x raised to 2m minus y square into y raised to 2m. Okay, now we can calculate the value of maybe x raised to 2m or y raised to 2m, right? So x raised to 2m will be equal to x plus y into k plus y raised to 2m, right? We just sent y raised to 2m this side. So x raised to 2m can be written as like this. So x raised to 2m, I just named this equation as 1. I put up the value of x raised to 2m over here. Okay, so it is x square and x raised to 2m is x plus y k plus y raised to 2m, right? This is the value of x raised to 2m. Then this is left y square into y raised to 2m. Okay, so here x square and x raised to 2m we have written x plus y k plus y raised to 2m. So this is the value of x raised to 2m. Okay, now we open up the bracket. It's x square into x plus y k plus x square into y raised to 2m minus y square into y raised to 2m. Okay, so it is x square x plus y k plus, from here I can take y raised to 2m as common, then it is x square minus y square, that can be written as x plus y into x minus y. Now you can see x plus y can be taken as common, and to remaining story we can write down as some other constant, that is lambda, right? That means Pm plus 1 is divisible by x plus y, right? So Pm plus 1 is true whenever Pm is true. So hence by principle of mathematical induction, it is true for all n belongs to natural numbers. Okay, so how simply we can solve all the problems based on mathematical induction, you might have observed, right? Standard steps are there, and 8 to 10 marks are absolutely free for you. Now this, once again same, Pn is equal to 3 raised to 2n plus 2 minus 8n minus 9. P1 is, it is divisible by 8, so let's see, it is 3 raised to 4, that is 81 minus 8 minus 9, so it is 64, that it is divisible by 8. That means P1 is true, right? So let Pm be true. That means 3 raised to 2m plus 2 minus 8m minus 9, it is divisible by 8. So I can write this down as 8k. Okay, make it simple. 3 raised to 2m into 3 square, that is 9, minus 8m minus 9 is equal to 8k. Okay, so 3 raised to 2m is equal to 8k plus 8m plus 9 by 9. Okay, that is the value of 3 raised to 2m. Okay, now we have to prove Pm plus 1 is true. So I write down Pm plus 1. So it is 3 raised to, instead of m I'll write down m plus 1. So it is 2m plus 2. Okay. So 2m plus 2, and we already have plus 2 over here. So this is this, minus 8m plus 1 minus 9. Okay. So it is 3 raised to 2m into 3 raised to 4 minus 8m minus 8 minus 9. Okay. Now I write down the value of 3 raised to 2m from here. So 3 raised to 2m is 8k plus 8m plus 9 by 9. Right. So I write down 8k plus 8m plus 9 by 9 into, this is 3 raised to 4 minus 8m minus 17. Okay. So this is 9 and this is 81, so it is 9 over here. So we multiply 9 into 8k, 72k, plus 9 into 8m, 72m, plus 81, that is this, into this, minus 8m minus 17. Okay. So it is 72k, 72m minus 8m, 64m, 81 minus 17, 64. So we can take 8 as common and remaining quantity can be written as lambda, right? So Pm plus 1 is divisible by 8. So that means it's true. Okay. So Pm plus 1 is true whenever Pm plus 1 is true. So hence by principle of mathematical induction, it is true for all n belongs to n, that is natural numbers. Right. So I have done good number of problems based on this divisibility type. Now let's take some more pattern of problems. Just write down all the solutions, problems and solution for 2 to 3 times, right? Similarly, we try this problem. Pn is equal to 1 into 3 plus 2 into 4, n plus 2 is equal to 1 upon 6, n plus 1, 2n plus 7, right? So we find out P1. So that is 1 upon 6 into 1 into 2 into 9, right? So that is 3. That means P1 is true. Now next is, as usual, let Pm be true. So Pm will be what? 1 into 3 plus 2 into 4 till m plus 2 is equal to 1 upon 6 m plus 1 2m plus 7, right? That's true, that we have assumed. Now we have to find out Pm plus 1 is true. So Pm plus 1 is equal to 1 into 3 plus 2 into 4 till m plus 1. Instead of m I'll write down m plus 1, so it is m plus 1 m plus 3 is equal to 1 upon 6 m plus 1 m plus 2 2m plus 1, so it is 2m plus 9. That we have to prove. Okay. So I write down Pm plus 1, that is 1 into 3 plus 2 into 4 m plus 2 plus m plus 1 m plus 3. Okay, that is Pm plus 1. Now up to here, up to m plus 2, the value of this is 1 upon 6 m plus 1 2m plus 7. So I just replace this by this. So it is 1 upon 6 m plus 1 2m plus 7, and then we are left with m plus 1 m plus 3. Okay. Now I can take m plus 1 as common. Then we are left with 1 upon 6 m into 2m plus 7. So it's 2m square plus 7m. Then over here m plus 3 is there, so if you take LCM it will be 6m plus 6 into 3, 18. Okay, and by 6 is already there, so it is m plus 1 by 6. It is 2m square plus 13m plus 18. Okay, so 18 into 2, 36. So factors can be done 9 and 4. So m plus 1 by 6, 2m square plus 4m plus 9m plus 18. So it is m plus 1 by 6, 2m is common, m plus 2 plus 9 is common, m plus 2. So it is m plus 1, m plus 2, 2m plus 9 by 6. And that only we had to prove, right? We have to prove this. Okay, the same we have got, right? Hence Pm plus 1 is true whenever Pm is true. So hence by principle of mathematical induction, the same sentence you have to write down. Okay, so good number of problems we have done in this session. One last pattern is left, so that we'll discuss in the next session. Bye bye.